All right, this is lesson 2, standard form of a quadratic function. So lesson 1, we talked about vertex form. Now we're going to talk about standard form. So our essential question is, what key features can you determine about a quadratic function from an equation in standard form? Here's our table of contents. All right, finding the vertex of a quadratic function in standard form. So a function written in standard form is in the form y equals ax squared plus bx plus c. We did see this a little bit in vertex form when we had to change vertex into standard form, okay? You can derive the standard form from the vertex form by doing that. So again, I'm looking for that ax squared plus bx plus c, okay? So if I have vertex form a times x minus h squared plus k, I can factor out the x minus h. So x minus h times x minus h gives me x squared minus xh plus h squared. So that gives me 2xh plus h squared. Okay, I can multiply that a through everything. So I get ax squared minus 2axh plus ah squared plus k. So my a value is a, it doesn't change. My b value is going to be that 2axh, and my c value is going to be ah squared plus k. So what is the vertex of the function y equals 2x squared minus 3x plus 5? Okay, so the first thing that we need to do is determine what our a, b, and c are. In this case, our a value is 2, our b value is -3, and our c value is 5. Okay. Then I can use what I just found, where b equals -2ah, and solve that for h. Okay. So I get h equals b over -2a. Okay, and then I can just simply solve that. So I can substitute the values in for a and for b, and I can find my h. In this case, my h is going to be 1.33, or 4/3. Okay. Then I can substitute that value into my original equation and solve for y. So f of 4/3 equals 2 times 4/3 squared minus 3 times 4/3 plus 5. Okay, and I get 41/9 or 4.55. Graph a quadratic function in standard form. So how can you use key features to graph f of x equals x squared minus 4x plus 8? So again, I'm going to determine what my a, b, and c are. So in this case, a is 1, b is -4, c is 8. I find the x coordinate for the vertex, okay, again, by taking b equals -4 and my a is 1 and substituting those values in to find h. So -4 divided by -2 times 1 is -4 over -2, which is going to give me +2. So my x value for my h, for my vertex, is 2. Okay. From there, I can figure out what my y coordinate is by substituting the value of 2 into my equation. So f of 2 equals 1 times 2 squared minus 4 times 2 plus 8. So I get 1 times 4, because 2 squared is 4, minus 8 plus 8, which simplifies to 4. Okay, so my y value for my vertex is 4. So now I have my vertex, 2, 4. From here, I can find the y-intercept of my function. I can do this by substituting 0 in for x, since I'm looking for where it crosses the y-axis, not the x-axis. So in this case, I substitute 0 in. 0 squared is 0, times 1 is 0, 4 times 0 is 0, 0 minus 0 is 0, plus 8 gives me +8. So my y-intercept is that c value in the end. I can find a point that is symmetric to the y-intercept across the axis of symmetry. So in this case, my axis of symmetry is 2, x equals 2. So we can double this to get the third point of 4, 8. So I knew my y-axis was 0, 8, right? The C value that I had. I found my vertex of 2, 4. Okay, so I moved this point. Okay, well, I moved 2 units to get to that axis of symmetry. So if I move 2 more, it should mirror each other. Because again, that axis of symmetry is like, if I folded the parabola in half, it would be a mirror image of each other. Interpret the graph of a quadratic function. So if I have price, demand, revenue, right? Example, the graph of the function f of x equals negative 10x squared plus 700x minus 6,000 shows the profit a company earns for selling headphones at different prices. What is the maximum profit that the company can expect to earn? Okay. So I'm basically interpreting this. The x-axis is showing me what my selling price is, and my y-axis is showing me how much profit I'm making. So really, I want to find the maximum profit. And since this is a quadratic function, I'm looking for the vertex of my graph. Okay. So if I look at this, I can't just automatically tell exactly what my vertex is. I can take a guess. It's probably somewhere between $30 and $40, and it's somewhere in between 6 and 8,000, probably closer to 6,000 than the 8,000. Okay. So the first thing I want to do is I want to find my x coordinate. Again, I know what my b value is, okay, and I know how I can find my h value. Okay, so in this case, my a is negative 10, my b is 700, so I substitute those values in. 700 for b and negative 10 for a. That gives me 700 divided by negative 2 times negative 10, which is positive 20. 700 divided by 20 gives me 35. So I know what my x coordinate is. From there, I can figure out my y coordinate, right? So I substitute the value of 35 in for x and I solve. When I get that, I get $6,250. Okay, so that tells me the vertex is 35,6250, so 6,250. So the selling price of $35 per headphones is going to give me my maximum profit of $6,250. Write the equation of a parabola given 3 points. So I want to write an equation that passes through the points 3, 5, 6, negative 4, and 8, 0. Okay. So what I need to do is I can write 3 equations using the x and y values. So in this first equation with this first point, I have 3, 5, right? So I substitute 3 in for all of my x's and I substitute 5 in for y, and I simplify as much as possible. Okay. I do the same thing for 6, negative 4, and for 8, 0. Okay. When I do that, for my first equation, I get f of 5. I get y equals, or 5 equals 9a plus 3b plus c. Then I get negative 4, 36a plus 6b plus c. And then I get 0 equals 64a plus 8b plus c. Okay. From here, I want to set up a matrix. Okay. So very similar to what we did in unit 1, right? So I'm literally taking the numbers, A, B, C, the numbers that are out in front of those letters, and my f of, or my y value. Okay. And that's what's going to equal. So now I have this matrix. I can put it into a graphing calculator, or I can sit and solve this. I can sit and solve the matrix if I would like to, or you can use Desmos as a matrix solver. Okay, but I want to get it into reduced row echelon form. So in this case, my matrix is A is 1, B is negative 12, and C is 32. So then I'm going to substitute those points back in. In this case, I'm substituting the point A for 1, B is negative 12, and C is 32. Okay, and then I'm just going to graph it to confirm. So it did pass through those 3 points that I had indicated, 6, -4, 8, 0, and 3, 5. Okay, so it does give me that parabola. Use quadratic regression. So one of the easiest ways to do quadratic regression is either to use a graphing calculator or to use Desmos. I'm going to show you how to set it up in Desmos because that's the way that we will usually use quadratic regression in our class. Okay. So the first thing that you want to do is create a table in Desmos, and you just do this by clicking on this little plus sign and then creating a table. You want to make sure that it says X1, Y1. Okay. So in this case, I have the data from 0, 2.2, -1, 1.1, and 1, 2.1. Okay, so I substitute those values in for my X and my Ys. Then I'm going to type in the quadratic regression equation, Y sub 1, and then a tilde, okay, AX squared sub 1 plus BX sub 1 plus C. If you don't include the tilde, and if you don't include the X sub 1 or Y sub 1, you will not get, it'll come up as an error. It won't do anything for you. Okay. You have to make sure that you've got that X sub 1, Y sub 1 in there. Okay? So in this case, once you do that, it automatically does the quadratic regression for you, and it gives you your value for A, B, and C. And then you just substitute those values in. If you need to evaluate the expression, you just simply type in Y equals A sub whatever the case, whatever value you wanted in for X, squared plus B, your value for X plus C. In this case, they wanted to do 10. Okay. And it came up with the solution for you. You can also type in like 10 squared A plus 10B plus C. And it'll give you your answer for you. All right, so Esteban is training for the discus throw. His coach recorded the horizontal distance and height of one of Esteban's discus throws. The graph shows the horizontal distance the discus traveled in meters and the height of the discus in meters. What will be the height of the discus when it has traveled 15 meters from Esteban? Okay. So right now we're only seeing a linear side of this, but in reality, it's going to be a quadratic equation because it's going to fly up and then reach a peak at some point and then fly back down. So we want to use the values that we are given in order to determine what the equation is going to be, as well as what it would be valued at 15 meters. Okay. So I'm going to create a table in Desmos. And then I'm going to create the quadratic regression in Desmos. When I do that, I get this equation. So the data shows the disk is only rising, but the model would resemble a parabola. So in this case, we get y is approximately -0.270x squared plus 1.058x plus 0.672. I then substitute the value of 15 in for x, and I solve. Okay, so again, you can put it in Desmos. It's going to give you the answer of around 10.467. So based off of the information that we are given, we can determine that at about 15 meters, the discus should be about 10.5 meters. Summary. So basically in standard form, I have ax squared plus bx plus c, or I can have vertex form a times x minus h squared plus k. When you're doing standard form, you can make a table or use the table function on a calculator or Desmos to help you. Negative b over 2a will tell you where the vertex is because it's going to give you that x coordinate for your vertex. C is still your range, but it's also going to be your y-intercept when you solve these equations. And that is the end of lesson 2.